Okay, like I said in class, I'm not going to explain all of these, but I am going to explain those that I think you might have some trouble with. So really quickly, if we talk about questions like 3 and 4, both of these are slope-intercept. So we're going to start, here I started at -2, and then I counted my slope as 3 over 1, so I'm going to go up 3 and over 1, or we can also go down 3 and to the left 1. Similarly on 6, I'm not adding anything out here, so I'm going to start at 0, and my slope is down 3 and right 4, or I can go up 3 and left 4. Remember, you have to think about this as putting the negative sign in one place. You can't put the negative sign in both places, so it can be -3 over 4 or 3 over -4. On questions like 4 and 5, both of those, if you can do intercepts, you should, but if they don't divide, or like on 5, if you don't have enough room to graph 20, then you've got to rewrite those equations in slope-intercept form, which is what we've been working on for a few weeks now. So if I subtract 8x, that gives me 5y equals -8x plus 25. And this week we said we want to divide everything individually, which gives us y equals -8 over 5x plus 5, and then we're just back to graphing slope-intercept form. All right, very similarly on 5, I'm going to subtract the x, so -4y equals -x plus 20. That's like -1x. Divide by -4. When you divide by negative, that's going to cause some sign changes, so I've got y equals positive 1/4 x minus 5. And that's the line that they have graphed here. All right, question 7, anytime you just have a y equals or x equals line, it's going to be completely horizontal or vertical. So I know this is y equals -1, and I need it to cut just through the y-axis, which is going to cause the line that you see right here. On 8, we could do cover up, but that's going to cause me to have an intercept right here, which means I don't know how my line runs. So again, I need to solve for y. So -y is going to equal -x plus 0, divide by -1, which is going to give me y equals x, or y equals 1 over 1x plus 0, however you need to write that. You should recognize that this is our parent function, our most basic line. On 9, the easiest thing to do is cover up and find that the x-intercept is -1 and the y-intercept is +1. That's because you have -y equals -1, and that's why you get +1 in the end there. On 10, again, you're going to have to solve. So -y equals -3x plus 2, or y equals 3x minus 2 when you divide everything by -1. And then graph using slope-intercept. Question 11, again, start at -1 on the x-axis. This time we're cutting through the x-axis because it says x equals. And 12, remember 12, start on 4, and you should do rise 5, run 2. But since you run out of room, you've got to go backwards, which means you have to go down 5 and to the left 2 to find your previous point. Same thing again. Make sure that you double check always your slope, because this looks positive, and my equation said I needed a positive slope. So you just want to check that and make sure you haven't accidentally counted backwards, specifically if you run out of room on a graph. All right, question 13. You're just identifying where are you starting. That's at -4. And then find 2 points so that you can count your slope. -7 over 2 because you're going down. Same idea on 14 and on 16. And remember, question 15, completely vertical or horizontal lines are either x equals or y equals. And because this is cutting through the x-axis, it's going to be x equals. All right, so remember that most of the time when you're going to be writing equations, you're going to start with your point-slope form, which is going to be y minus y1 equals m times x minus x1. So that's where you should start every single time. Not paying attention to even what the directions say, that's where you need to start. Which means on this first one, on 24, I'm going to do y minus 2 equals 3/4 times x minus 4. And then we're going to need to distribute. So now we just need to pay attention to our directions, slope-intercept form. So that means I need to get y by itself. So I'm going to distribute y minus 2 equals 3 over 4x minus 3/4. Those 4's are going to cancel, so that's just going to be minus 3. And then I need to, like I said, get y by itself because it's slope-intercept, so add 2 to both sides, which is going to give me the final equation, y equals 3/4 x minus 1. Now 25 and 26 are a little different, still start the same. Remember, always going to start in the same spot, except now we're going to do standard form. So I'm going to start in the same spot, y minus 3, y plus 3. Remember, you got to do opposite of what the symbol or what the sign is. Equals 1/2 x plus 4. Distribute. Y plus 3 equals 1/2 x plus 1/2 of 4 is 2. And now standard form means x and y on the same side, no fractions. I think it's easier to get rid of all the fractions right now, and we do that by multiplying by the denominators. So that's going to give me 2y plus 6 equals, those cancel, 1x plus 4. And then move my x and y, so I'm going to subtract the x to this side, which is going to give me 2y minus 1x, or negative 1x plus 2y. And then I want to also subtract the 6 from the other side, which will give me, if I subtract 6, that's going to give me negative 2. Notice that all they've done here, if you pay attention to the answer, is they've changed the signs. You don't have to worry about changing any signs on your test. I will count this answer right here just as correct as the other answer. 26, very similar. Always start in the same place. Y plus 2 equals 1 times x plus 3. Remember, y with y, x with x, opposite signs. And then distribute. Y plus 2 equals x plus 3. X and y on the same side, so y minus x. If I subtract that over, and then subtract 2 equals 1. Notice that they have the exact same thing, except every single sign is opposite, and that's okay. Don't worry about changing signs for your test. All right, always going to start in that same place that we just said. The difference here is that they give us 2 points. So we actually have one step we have to do first, and that's find our slope. So I'm going to do y2 minus y1 over x2 minus x1, which is going to give me 2 over 3 here. And then now you just pick a point. It doesn't even matter which one you pick. All right, so that's y equals, y minus 0 equals 2/3, x minus, plus 3. Make sure you change the sign. And then we're going to distribute. Y minus 0 is just y. So 2/3 x, and then these 3's cancel each other when you distribute. So that's going to be plus 2. You would get the same thing if you had picked the other ordered pair when you worked all of that out. All right, 28. Remember, start in the same place. We got to find the slope first. So negative 4 minus negative 5, y2 minus y1, x2 minus x1. When you go through and change all the signs there, you should get positive 1 over positive 4. And then you're just going to pick a point to multiply by. So I'll pick this first one. So y plus 5 equals 1/4 times x plus 1. Distribute. Y plus 5 equals 1/4 x plus 1/4. And I think you all told me in class that you thought it was easier to get rid of the fractions and then kind of work back around. I'm not sure if that's true or not, so I'm just going to subtract 5 so we keep the same pattern. But remember, when you do this little subtraction here, you need to have the same denominator. So 1/4, if I want to subtract and have the same denominator, I'm going to have to make this top number 20, because 20 divided by 4 is 5, which is going to give me a final answer of y equals 1/4 x minus 19 over 4. All right, 29 and 30. Same place, still got to find our slope to begin with. 0 minus negative 5 over 2 minus 0 is 5 over 2. And then pick a point. Y plus 5 equals 5 over 2 times x minus 0. Distribute. Y plus 5 equals 5 over 2x. And now my directions say standard form, x and y on the same sides, and no fractions. So I'm going to get rid of fractions first, multiply everything by 2. 2y plus 10 equals 5x. Remember, you pick 2 to get rid of that denominator. And then now x and y on the same side. So if I move 5x over, that gives me 2y minus 5x. Move the 10 to the other side, equals negative 10. They have the same answer, opposite signs. That's okay. Okay, last one. Again, start with the slope. Negative 3 minus 4 over 0 minus negative 3. That's going to give me negative 7 over positive 3. Pick a point. Y minus 4 equals negative 7 over 3 times x plus 3. Y with y, x with x, opposite signs. Now we're going to distribute. Y minus 4 equals negative 7 over 3x. Remember, the denominators cancel, so minus 7. I still need to get rid of my denominator, so I'll even have to take a step further, multiply everything by 3, because I have one more denominator left. So that's going to give me 3y minus 12 equals negative 7x minus 21. And then x and y on the same side. The only thing I have left to do for standard form. So I'm going to have 3y plus 7x when I move it over. And then to move the 12 over, I have to add 12, which is going to give me negative 9. All right. Okay, this last little section here is we're talking about what information you can gather from each equation. So notice anything that's in standard form, 31 and 32, excuse me, those you can find the x and y intercepts. That's just cover-up method. So pay attention to that. On this 33 and 34, I can't read numbers today, those are both point slope form. And from those, you can see the ordered pair. Make sure that you read it backwards and opposite, x with x, y with y. And you also see the slope, similar in 34. And then 35 and 36, this is slope-intercept form. And in slope-intercept form, we can obviously see the slope and the y-intercept. That's why they call it slope-intercept form. All right, almost done. This is talking about transformation, so it's the things when we talked about being more steep, less steep, shifting up, shifting down, or having a reflection. So we're comparing everything to our basic function, which is y equals x, or you can think about that as y equals 1x plus 0. So the changes on 7, there's a negative in the front. Anytime you multiply by a negative, that's going to change the slope to be negative, and we call that a reflection. And then plus 9 is going to shift. Our whole graph, it's changing the y-intercept, so it's just going to pick my line up and move it up 9, and that's called a shift. All right, 8, a 3 is going to make it steeper. Remember, anything greater than 1 is going to cause the line to be steeper. You'll see on question 10, that's happening again, steeper. The negative 8 on question 10, I know I'm going out of order here. The negative 8 is going to shift down because I'm changing the y-intercept. Question 11, the plus 5 is going to shift up. Question 11, there's a few things going on. I also have a negative, which we'd already talked about, means reflect. But the 3/4 here, the fraction is going to actually make it less steep because 3/4 is smaller than 1, which is my original slope. So this is going to be, if I could spell, less steep. And you should see that that's similarly going to happen on 9. It's going to be less steep. So anytime you see an equation, anything that's different, the most possible things you could have are 3, which is going to be something that would have, like question 11, a reflection, a change in steepness, and a shift. You may not have any change in steepness or any shift, and that's okay. You just need to pay attention to what's different from the original equation. All right, last problem. I don't have the directions on here like I should, but we're going to be comparing domain and range and talking about the steepness of each graph. So if we look, they have already given us information about a mouse, and if I go ahead and list everything I know about the mouse just from looking at the graph, The domain for the mouse, domain or x values, is 0 to 8. That means he traveled for 8 minutes, 0 to 8. The range, those are my y values, and it looks like he covered a distance of 300, so that's 0 to 300. The steepness is like the slope, and we can get that by dividing 300 divided by 8 because that's how quick they went. And for that, I get 37.5 as the rate. All right, we'll use that here in just a minute. For the gecko, they give me the information in the table. It says the gecko travels for 6 minutes at a constant rate of 19 meters per minute. So 6 minutes is how long he's traveling, which means that's the only amount of the graph that I should use, and it's 19 meters per minute. So the gecko's going to start at 0, and if I do 6 times 19, I get 114. So 6 times 19, if I graph that, let's see, 114, that's down here. All right, so if I talk about the gecko's domain and range, domain, again, are x values, so that's 0 to 6. Range are my y values, which is going to give me 0 to the y we just said was 114. And then the steepness here is going to be the rate that we just found, which was a rate of 19. So if you look at the graph, you should notice that the mouse is steeper. So the mouse is steeper. The mouse also traveled a further distance because it went 300 meters versus 114. And it traveled for a longer amount of time because it traveled for 8 minutes versus the gecko only traveling for 6 minutes. So the mouse was quicker, ran for the longer amount of time, and went a further distance.